Welcome to the Tellabs Basic Series video, Power over Ethernet. This video is designed to help you better understand the Power over Ethernet standard and how it is configured and supported by the Tellabs Optical LAN system. The topics covered in this video will be PoE Basics, PoE Power Management over LLDP, Tellabs PoE Powering Capabilities, and Tellabs PoE Configuration. Tellabs Optical LAN systems are designed to support the full spectrum of LAN service devices. Modern LANs require the support of devices like voice-over IP phones, Wi-Fi access points, building automation, and security surveillance cameras. All of these devices can be powered securely and conveniently using a power source called Power over Ethernet, or PoE. PoE offers many benefits. It provides dramatic cost savings in deployment by eliminating the need for electrical outlets, thus removing the need for bulky AC power adapters. It simplifies installation by using a single CADX cable for both data and power. It centralizes power backup, providing continuous operation during power interruptions. Management of power is also centralized. Devices can be remotely powered down during periods of low usage or for security purposes. Lastly, it provides safe power. It will not damage non-PoE devices or legacy peripherals. PoE is a 48-volt DC power source that travels over the Ethernet circuit from the power source equipment, or PSE, to the power device, or PD. In Tellabs Optical LAN, the ONT is the power source equipment. PoE is transparent to the Ethernet link. It travels on a phantom circuit through the center tap of the transformers over the data pairs. Since Ethernet is AC, PoE does not affect the Ethernet traffic. Power source equipment is categorized by type depending upon the power requirements. The initial standard for PoE, Type 1, provides a maximum power of 15.4 watts to the port. PoE Type 1 can support devices such as voice-over IP phones, wireless access points with 2 antennas, and simple static surveillance cameras. Type 2 PoE, or PoE Plus, is backward compatible with Type 1 supported devices and can support devices such as more complex surveillance cameras, as well as wireless access points with 6 antennas. Type 3 and 4 PoE is also called 4-pair PoE. Type 3 provides 60 watts of DC power, and Type 4 provides 100 watts to each PoE port. PoE Type 3 and 4 can support devices such as digital signage and advanced pan-tilt-zoom cameras. Link Layer Discovery Protocol is defined by the 802.3 standard. Using LLDP, a power device can send information to the ONT about PoE fine-grained power control. This enables an endpoint to communicate a more precise required power level, thereby enabling the device to allocate less power to the endpoint, while making more power available to other ports. Tellabs Optical LAN provides a variety of PoE capabilities. The ONT 729 provides a maximum of 450 watts of PoE power shared by 24 ports and supports Type 1 and 2 PoE. The ONT 140 series supports a maximum of 60 watts of PoE power across 4 ports and supports Type 1 and 2 PoE. The ONT 131W provides 30 watts of PoE power across 2 ports and supports Type 1 and 2. The ONT 180C and ONT 205 both support a maximum of 140 watts of PoE. They support Type 1, 2, and 3 PoE. And the ONT 202 supports a maximum of 120 watts of PoE. It also supports Types 1, 2, and 3 PoE. PoE power available on the ONT 248 depends on the power supply used and the redundant power option. The maximum PoE power available on the ONT 248 is 2100 watts using 2 1100 watt power supplies in a non-redundant configuration. Notification thresholds should be set accordingly if redundant power is required. The Panorama EMS provides a variety of PoE status indicators. At the ONT configuration window, the PoE operational state defines whether the PoE power circuit is operating normally. Values are up, down, or faulty. Faulty indicates total power draw exceeded or a PoE hardware issue. Nominal PoE power defines the maximum PoE power that is available to the ONT PoE circuits. This is calculated as external power minus ONT base power and losses. Allocated power is the total of all PoE power requested from the attached PoE devices on all ONT ports. Delivered power defines the measured number of watts being delivered to attached devices via PoE. In the Uniport property dialog, the PoE tab shows information about PoE on an individual Uniport. Detection status indicates whether a PoE client has been detected and whether power is being delivered. Status can be searching, deliver power, or fault. Allocated power is the power the ONT has reserved for the port, and delivered power is the actual measured power that is being delivered to the PoE device. Panorama allows the user to set templates and profiles for PoE. In the ONT template, ensure that the external power settings are properly set. The 140 series ONTs are set to 75 watts. The 180C and 205 ONTs are set to 150 watts. And the ONT 729 is set to 600 watts. If ONTs are remotely powered, these settings may need to be adjusted. For the ONT 248, set this threshold according to the power supply installed in the unit and the power redundancy requirement. This will ensure that power redundancy is retained even if the ONT is not close to a power shedding situation. Usage threshold alarms are enabled if they are to be turned on. The PoE profile controls the power priority. Power priority can be critical, high, or low. When the ONT is forced to power shed, lower priorities are shed first. If all priority is equal on the ONT, the lowest numbered ports are given the highest priority. The power override feature sets a maximum negotiated power for the port. Using this feature can help reduce the instance of oversubscribing PoE power on the ONT when devices negotiate more allocated power than they actually need. The LLDP profile can be configured to support PoE attributes as well. In the 802.3 attributes, the power via MDI can be enabled to allow the end device to communicate a more precise required power level. In the LLDP med attributes, it is best to enable extended power via MDI as well. Doing both ensures that the port will support devices of either standard. In the service port configuration, the admin state controls both PoE and Ethernet. If the Ethernet admin state is disabled, then the PoE power will be denied as well. An LLDP profile that enables LLDP should be applied to the port, as well as a PoE profile that enables PoE. On the Tellabs PON system, the PoE default is enabled. This concludes this video. In it, we have learned PoE basics, PoE power management using LLDP, Tellabs PoE powering capabilities, and Tellabs PoE configuration.